Write a program to control the level in the tank. When the level is less than 10%, turn the low level alarm on. When the level is less than 25%, set the VC100 to 100%. When the level is greater than 75%, set the VC100 to 0%. When the level is greater than 90%, turn on the high level alarm. Each line in our program specification can be translated into one line of code. Write a program in Ladder and test it with the Exercise 4 operator screen. Save your program. Write the same program in function block using the variable shown below. Test the program with the Exercise 4 operator screen. Save your program because you will need it in the next section. Different data types are stored differently in the PLC. Some library functions use specific data types. You may need to convert from one type to another. For example, integers are whole numbers and are stored in 2 bytes. Real numbers are stored in 4 bytes and include the whole number plus the decimal places and an exponent. Here is an example of an integer to real function block. We need to convert a range of numbers to another range. For example, 0 to 10,000 counts represents the values of 0 to 800 millimeters of the process. Rather than displaying a percentage on the operator screen, we may want to display the values of the process. We could write a program to perform this, or we could use the scaling function provided. The maximum and minimum values of the input and the minimum and maximum values of the output are provided, and the scaling function will do the calculation. There are 2 inputs on the left. The variable input, which is the value that we are going to scale. Note this needs to be a real number. The parameter input contains the values of the input min, input max, output min, and output max. The scaled output appears on the output pin as a real number type. The status word can be decoded to highlight any errors in the calculations. The parameters input of the function is a special type of variable that contains subvariables. This particular one has 5 subvariables. The parameter variables are in the derived variable section of the project browser. You will see the variables that are created for this project. Open up these variables by clicking on the plus sign and you will see the subvariables in-min, in-max, out-min, and out-max. You will also notice that we have put values in here already. You can access these values using the format shown on the screen, but for our example we can use the variables already supplied. I mentioned earlier that the scaling function needed to have a real number input for our process variable as an integer. So we're going to need to convert the integer to real. On the ladder diagram, the link joining the int to real to the scaling function needs to be drawn using the link tool. A subroutine is a section of program that only runs if it is called. They are located in the project browser under SR sections. You would have seen how you can have more than one section. When the program is running, it will complete one section after another from top to bottom. The SR section is only run if the section is called and is called from one of the section programs. Generally, subroutines can only be called once with the PLC cycle. You can call a subroutine from another subroutine. Create a subroutine by right-clicking on the SR sections. Let's say we have a program that has 2 modes of operation, summer and winter. The program will step through testing whether it is summer or winter on each line. This will add to the execution time of the program. It will also result in a program that may be hard to follow because it is all mixed up. If it is divided into subroutines that are only run at the appropriate time, then the program will be more efficient and easier to follow. With the ladder diagram, the call coil is used to call the subroutine. Firstly, create the subroutine. Secondly, place the call coil on the ladder rung in the main program. Then double-click the call coil and the properties window will open and the list of subroutines will show. Select the one that you want to use and click on it. With the function block diagram, the SR call is used to call the subroutine. Click the SR tool to place the SR call on the screen. Notice how the enable pin is on by default so that the subroutine call can be conditional. Double-click on the SR name pin to select the subroutine from the subroutine properties window. Your subroutine doesn't have to be a function block if your main program is function block. It can be ladder, structured text, function block, or instruction list. Here is an example using a switch to select one subroutine or another. If the mode variable is on, the level subroutine is executed. If the mode variable is off, then the purge mode is executed. Both function block and ladder diagram are shown. Now to complete exercise 5. Add scaling and a subroutine to the program that you developed for exercise 4. In the subroutine, scale the variables LT100 to 0 to 800 millimeters and FT100 to 0 to 6 liters a minute. Test the program using the exercise 5 operator screen. Now complete the project to assessment.